Hi everybody! Today we have kind of a throwback to Gen Chem 1. What we're going to be doing is going back to the basics and just reviewing how many bonds and how many lone pairs or electrons a lot of these common elements in organic chemistry are going to have. So we're just going to be focusing on the main ones like hydrogen, carbon, nitrogen, and so on. So when you're trying to determine how many bonds or how many lone pairs one of these elements is going to have, you can use the periodic table and try to read it almost like a left to right book. So for example, if you are an element and you take electrons, let's say fluorine here, you would move to the right. The goal is to get to be in this noble gas area with the amount of electrons you have, which we're going to consider 8 for now, just because that's the basic octet, and your element will be happy, as they say. If you give your electron, let's say we have hydrogen giving an electron, you move left. So you can jump all the way from this side to here. But I have a couple examples with pictures just to make that make more sense for you. So we're going to start off with number 1, probably the most simple element, which is just hydrogen. As you can see, here's a really nice valence electron diagram from pubchem, and shout out to ACS for the periodic table. So you can see there's just one valence electron. So you have two options. We're starting here. You can either try to take 7 electrons to move over here, which is just not going to happen, or you can give up your 1 electron to move left and get into that happy state. So that's why you're going to have one bond formed with hydrogen, and hydrogen's considered to be positive, and it'll donate its proton. Next we have probably the most important element in organic chemistry, which is going to be carbon. So you can see carbon right over here. So carbon's neat because you can either take 4 or give 4 to go to the right or the left to get your happy octet. So you're not really going to see lone pairs on a carbon. What you're going to see is bonds instead. I'm going to draw this out in a little bit to help you out. But you can get single bonds, double bonds, or even triple bonds. So long as carbon has 4 bonds, it's going to be pretty happy. So here I've switched us over into a whiteboard mode. And I just want to show you how you could approach this to see through the chemistry how the bonds are formed. So we'll draw out carbon here, and just remember you only need the valence electron. So I'm just crossing off the other electrons. So we would have 1, 2, 3, 4. So now you can clearly see that you are 8 away from forming your octet. So that's why you're typically going to get 4 bonds. And I'm just going to do the simplest molecule I can, which would be methane, or just carbon and hydrogens. So as you can see here, carbon and 4 hydrogens makes a pretty good pair. So that's how I would take a valence diagram with the core electrons too, and then just see it in my head as how that makes 4 bonds. Another common molecule that you might be seeing is nitrogen. So as you can see, nitrogen's right here, and it's going to be much easier for nitrogen to take 3 electrons than to try to give up 5. And here in the valence diagram you can see these 5 electrons, and you might be able to visualize it, but if not, I'll draw it. These 3 on the outer right here would form the bonds, and these 2 would actually end up forming a lone pair. So nitrogen comes in a couple different ways you can bond. You can do 3 single bonds, a single and a double, or 1 triple bond. So here we're back into whiteboard mode, and let me show you how I would do this one. So remember, we only care about the valence electrons. We have nitrogen, and see we're 3 away from getting 8. So I'm actually going to just draw in right away these 2 that aren't going to be used in bonding. They're just going to be a lone pair. And why don't I put these in red here? And these 3 these will be used in bonding. So that's why you're often going to get one triple bond, or a double and a single, or you could get 3 singles. So I'm just doing a triple bond, but they're all fine to do. And I'm just going to put that with the carbon right here. We'll make a nitrile. And then of course this guy isn't going to have any lone pairs, but he will be needing some type of bond over here. But this part isn't as important. Just wanted to demonstrate how I would show nitrogen needs that amount of bonds and has that amount of lone pairs. So here we have oxygen, and oxygen is going to be right here on the periodic table. So as you probably figured out the pattern by now, you can either take 2 and go right, or give 6 and go left. We're going to be taking 2 and we're going to be going right. Here's a couple common examples of what you might see. These are actually functional groups. So oxygen either is going to want to form a double bond like this, or it will form single bonds with 2 different molecules. You might recognize like water would be H and then an O and then an H. Here's our valence diagram, which I will be bringing over and then showing you how I would draw that out. Alright, I'm just zooming in a little bit for you here. There we go. Here's our oxygen molecule, so we're going to be doing the same thing. Let's cross off the electrons that we don't need. We only care about the valence electrons. And remember, we're only 2 away, so I'll grab our red for the 2 that we are going to be using, like this. And then these other 4 are just going to end up being lone pairs. So let me circle those separately, like that. Alright, let me draw out for you what would happen. So we have our oxygen molecule, and I'm just going to add our lone pairs here and here, so you can see these just were brought down over here. And then in red, we're just going to go with a double bond because I think it's the most simple. We would have 1 here and then 1 here, just to clarify. So we have our double bond here, and we're just going to go ahead and attach it to a carbon. Now, as you know before, this carbon's going to need more stuff to it, more bonds to make it happy, but we only are really focusing right now on the oxygen part. So now hopefully you can kind of see how we're getting this structure from these electron diagrams. Okay, now we're almost near the end. We're at fluorine here, which is just 1 away from our noble gases. So obviously it's going to be a lot more beneficial if we just take 1 electron and we move to the right. You might be thinking like, oh, do you remember the word electronegativity? Remember that as you're getting closer to fluorine, both moving right and up in this corner, you're going to have electronegativity, which just means highly electronegative atoms really want to grab a proton from something, say over here, like a positive metal. So here you're going to see that we have 3 pairs of lone pairs, and this molecule and this group is really only going to be formed by 1 bond, and they do tend to be diatomic. That's why I chose to do like F2 or fluorine-fluorine, just because they really don't like to be existing in nature, and they're not stable if they're just floating around by themselves, or their ions are too electronegative that they'll be wanting to add to something. Alright, so we're back with our last diagram. Here's the orbital diagram for fluorine. So I'm just going to cross out what we don't need. We only need the valence electrons. And remember, for this one, we're actually only 1 away. So we're only going to need, let me grab red, 1 more bond with 1 more electron. So as you can see here, all 6 of these guys over here are not going to need to be used. So that's why when you draw this out, we're just going to drag these all down like this. So there we have our 6. We have 1, 2, 3, 4, 5, 6. And let me write the other one in red. We'll drag him down over here too. we only have one electron that's going to be needing to form that bond to reach our number 8 for our happy octet. So I'm just going to go ahead and draw that out. And again, this can go with anything that's going to give up one proton pretty willingly. In all honesty, fluorine's going to rip and tear into them pretty well, so yeah, it's pretty electronegative. So we'll just do hydrogen, because hydrogen is pretty easy. Alright, so that's how the fluorine diagram would look if you took it and tried to visualize it in more of a organic chemistry bond way. I wanted to include this I found from PubChem as well. I thought it was just a neat way that the information was organized. The circles might help you to visualize it better. I'm not going to talk about it very much because we already talked about it, but I thought it was pretty useful. And I just wanted to say thanks for watching. I tried a lot of new different editing techniques in this and formatting, so thanks for bearing with me when the formatting wasn't perfect. Anyways, good luck studying for your test. See you!